Today we're going to take a look at Common Vulnerabilities and Exposures, or CVE for short. The CVE was created back in 1999 by Mitre, a non-profit organization funded by the US Department of Homeland Security. Many services and advisories used to have their own vulnerability identifiers. This led to an overlap where vulnerability had multiple identifiers. It was also hard to keep track of all unique vulnerabilities. The CVE system was created to solve these issues by providing a common naming scheme for vulnerabilities. Now, the CVE system is not a database per se, but rather a dictionary of vulnerabilities and their corresponding IDs. A CVE consists of a list of entries. This includes an identifier, a short description of the vulnerability, and at least one public reference. The description is usually of the form saying that the problem in a version of a product results in an impact when exposed to an attack. The example shown here is one of the CVEs in the Ripple 20 series of vulnerabilities targeting IoT devices. From the description, we see that the TREC TCP/IP stack before version 6.0.1.66 allows remote code execution, and the attack is related to IPv4 tunneling. The National Vulnerability Database, or NVD, gets data from Mitre, but provides additional information, such as the severity of the vulnerability given as a CVSS score between 0 and 10, where 10 is the most critical. A weakness category known as a CVE ID. A buffer overflow weakness is an example of a CVE category. And a list of affected products given as a CPE string. Now let's look at our previous vulnerability, CVE 2020-11-896 in NVD. As before, we are presented with the CVE ID and a short description. Then we see the severity rating. Here the score is 10, meaning that this is a critical vulnerability. Further down on the page, we find a list of references, including tags to categorize the resource. This can be very useful if you want to find information directly from a vendor, a possible mitigation strategy, or even exploits. The vulnerability is categorized as CVE20, which is a group of improper input validation weaknesses. Last, we find the known affected software configurations as a list of CP strings. Here we see that all versions of TREC before 6.0.1.66 are affected. All in all, NVD is a great resource for finding information about public vulnerabilities. But who assigns the CVE IDs to begin with? Those in charge of assigning CVE IDs are known as CVE Numbering Authorities, or CNAs. A CNA may be a vendor, an open source project, bug bounty programs, and more. There are currently 130 registered CNAs, including Cisco, GitLab, and HackerOne. Different CNAs cover different areas. For example, VMware only covers VMware-related issues, whereas Cisco Talos covers third-party products it researches. A CNA requests a block of CVE IDs, which they use when they assign new vulnerabilities. Now, what should you do if you find a new vulnerability? You should contact the vendor with information about your findings and clearly describe the vulnerability. Here it is preferable that you follow the responsible disclosure model. This means that you do not disclose the information publicly until after a certain time has passed. This ensures that the vendor has time to analyze and hopefully patch the vulnerability, allowing their customers to stay secure. There is no universal time frame for responsible disclosure, but it's common to give the vendor between 30 and 120 days, but this may be longer for more complex and large-scale vulnerabilities. Hopefully, you now have a basic understanding of CVEs and how to use them.